Hello peeps, we are here in Creality Print 6 and today we are going to go over the basics of slicing a model. There are many more advanced features to be learned. However, today we are going to focus on going from an STL file to a sliced printable model. We will cover the most basic functions you need to learn and understand how to control in order to help you have a successful print. Let's have a look at the screen in front of us. Here in front of us is the workspace for the printer and the print bed currently installed in that printer. Before importing your model, you will want to get that set to the correct printer and print bed. To do that, look right here on the left side of the screen. Using this pull down, you will select your printer. If you do not see your printer, you will click on Select Remove Printers. In here, you will check the boxes for all printers you own and press Confirm. Now that your printer should appear on this list, go ahead and choose it. I will choose the Creality K2 Plus with a 0.6 nozzle. You will now see your K2 Plus is selected, and on the right you have printer profiles for the K2 Plus. Back to the left, underneath the selected printer, are the available print bed types. The K2 Plus has a textured PEI bed, so we will go ahead and choose textured PEI bed. You will see the screen has changed to say Creality Textured PEI Plate. Should you be working with a different bed, simply pull down the menu and choose that bed. Again, you will see the plate will change to help you identify which plate you are working with. With your printer and bed chosen, it's time to import a model. For this demonstration, I will switch to a 0.4 nozzle, as this is the more typical nozzle size you are likely to be working with. In order to import your model, you can switch to a folder containing that model, hold your left mouse button, and drag it onto the bed. Or you may do File, Import, Import 3MF, STL, etc., etc. Select the file and press Open. In doing this, you may notice a warning about 1 million triangles. Models with 1 million or more triangles may be a little slower to work with. I have never encountered a situation where I have deemed it worth changing this. Simply disregard and press the X button. With our dog on the bed, it is time to prepare it for printing. We will be creating a G-code. What we are doing is creating a series of instructions and parameters the printer will follow in order to make this model. That series of instructions is known as a G-code. To get started, let's decide the size of the model we want to work with. I have imported this model, and right now we are looking at it 100%. However, let's say you own a large printer, such as the K2 Plus, and you don't want to work with this tiny little dog. You want something bigger. We will left click on this model, and we will click on Scale. You may also press the S key. Doing this will bring up the scaling tool. Inside this tool, you will see the X, Y, and Z parameters, as well as their percentage related to each other. Right now, it's 100%. With the uniform scale box checked, that means I can simply change any one of these parameters. For example, 150%. Scaling this model uniformly 150%, you can see our doggo is now much larger. In the event we had unchecked uniform scale and changed the x-axis to say 300, you'll see only the X rescaled, and we now have a pancake doggy. Let's go ahead and keep that uniform at 150%. Matter of fact, let's go 175% to make it easier for you guys to see. To exit that tool, you may simply press Escape or click away from the model. Before we start working with this model, we need to know how to look at this model. We do this by turning the entire print bed, not the model. The model right now is orientated exactly how it will be printed on the machine, and we will not be moving this unless we intend to affect how it will be printed. To look at the model without affecting its position, right-click off the model, hold, and turn left or right, up or down. This will help you look below the bed, above the bed, and all around the model. Should we want to zoom in, we can simply use our mouse wheel and scroll forward or back. This allows us to get close and far, while also being able to rotate and look around our model. However, let's say you zoom in and it's not exactly showing you what you want and you're kind of stuck here. Hold your mouse wheel and you may move the entire bed in order to get where you want to be on the model. Keep in mind, you are not moving the model, you are simply moving the view of the model. However, you can also move the model by using the Move tool. You can click on the model and press the letter M. This will bring you to the Move tool. Here you can grab any of these axis arrows by looking around as I just showed you and moving this model. If you are not someone interested in learning key commands, you may go ahead and simply click the Move command right here. You must first highlight the model and click on Move. You may also left-click on the model itself and drag the model around. You do not have to use these arrows. There are times where you want specific movement and the arrows are appropriate. For example, I don't want this model moving up or down at all by accident. I want an exact left or right movement. The arrow will allow me to do that. Notice once I click that arrow, I can move my cursor away and continue to have this exact movement with no worry of going up, down, or diagonal in any way. If I grab just the model, I can free float this thing and I won't have that exact control. You may do the same up and down. Moving the model upward will snap it back to the bed. However, you may place the model below the bed, which will come in handy for many technical and troubleshooting purposes. For example, if I only want to test the head because I'm having difficulty with the ears, I don't need to print this entire dog. I may slide it down just before the ears and run a test print to work on getting these printing appropriately. Then once I'm ready, I may go ahead and snap it back to the bed. This brings us to something important, which is the Lay on Face tool. You will see the dog is sitting on a flat surface and is orientated appropriately for printing. Since not all models will automatically import or have such an obvious flat surface meant for the bed, you may have to make these decisions yourself. For example, this big red machine mask. It imports on the bed like this, and this is not ideal for printing. I would like to stand this model up and most likely give it a slightly rear-leaning tilt. To do that, we can manually rotate this mask, or we can look at the available flat faces the model has to offer. We will do that by clicking the model and highlighting Lay on Face or touching the F key. You will see all of these potential flat surfaces. Let's try one. For example, this one right here. The mask is now positioned on that face. We may click it again, click on faces again, and look at other available options. This mask has quite a few, each one giving a little bit more of an angle, and of course the larger surfaces showing up as big solid white sections. Click on one and you'll see the mask has adjusted to that surface. Click on another, back to this surface, and we can try all of these various different surfaces to find the angle we might like. But what if we don't like any of these angles and we want to do it manually? This brings us to the rotation tool. We will use the doggo. Click on the dog, click on rotation, or press the R key. This will bring up the rotation tool. Here in the rotation tool, there are multiple ways to rotate this model. You can choose the axis and click the up or down arrow to move 5 degrees at a time. Or you can type your own in. I typed in 180 degrees and the dog turned 180 degrees. You may also grab this little blue arrow and rotate the model. You will see if I bring my cursor outside of this chart, there is no snapping. However, if I bring it inside this chart, you will see I can snap in 5-degree increments. Remember the mask we were working on earlier? Well, we can use the same rotation tool, rotating it on the x-axis to get that perfect angle we want for printing. Because bed snapping is active, when you release the mouse button, it will snap to the bed. Here you can go ahead and make even more smaller adjustments to get the angle just right for how you'd like to print this mask. This is a useful tool, not only for getting the proper angle for printing, but also for controlling the position of the model in the event you don't like where your Z-seam is placing. Rotating the model can give you additional options in an effort to relocate and hide that Z-seam. But Mr. Rundown, what is this sorcery? These are additional beds. Modern slicers allow you to work on more than one bed at a time. In Creality Print 6, you may work on multiple parts of your project within the same project, preparing individual print beds. Each print bed is intended to be printed separately on its own. There are many reasons you may want to work in a project with multiple beds. Let's start by learning how to make an additional bed. You do this simply by clicking this icon right here, Add Plate. You will see there's now a third plate. If I click it again, there's now a fourth plate. Go ahead and delete a plate by simply clicking the X in the corner of the plate. You will see the plate is now gone. Each of these plates can be named. For example, this plate has the dog on it. I may click this little pencil up here and type dog. The plate has now been labeled dog. I may click on this plate and label it Big Red Machine. And now the plate is labeled Big Red Machine. When working with models with multiple small parts, this labeling process is very handy. Now that we know how to navigate Creality 6's movement and scaling a little bit, let's say I have 5 kids and I want a dog for each kid. I don't want to print one at a time. I will need to go ahead and multiply this dog. In the slicer, we do what's called cloning. To clone this dog, right-click on the dog and select Clone. In here, it will ask how many copies you want. Keep in mind it currently says 1. That's 1 clone. Doing this will give you 2 dogs. If you want 3 dogs, you will clone 2 times. That's the current dog plus 2 clones. Pressing OK, you now have 3 dogs. You may clone as many as you like. However, you may run into instances where it's difficult to fit them all on the bed. This brings us to the Arrange tool. There are 2 different Arrange tools. One is here on each individual bed. That Arrange tool will affect only its bed. There is then a Global Arrange tool, which will arrange the entire project. If you have only one bed, this Arrange tool will affect only this bed. However, if you have multiple beds, the Arrange tool will attempt to arrange all models on all beds, and this may include attempting to stuff them all into the same bed. The parameters for your Arrange tool are hidden up here in this Arrange tool. To see them, left click. Once left clicking, you will see this pop-up menu with the Arrange tool. It offers a few useful parameters. For example, spacing. Let's say we want a certain amount of space between each model for one reason or another. By default, the Arrange tool is set to auto spacing. You can override this and set it manually by either sliding this slider or typing it in yourself. Keep in mind, we are talking millimeters. If I type 5, each model will have a 5 millimeter space. I recommend leaving it at auto unless you have a reason to change it. This checkbox here allows you to rotate the model for orientation. This sounds great because it can be very helpful in getting a lot more models on one bed. However, this can also create a problem. If you have a Z-seam in a certain spot, rotating each model in a different direction can affect where that Z-seam is placed for each model. For example, if I have the Z-seam running down the back of the dog and the dogs end up rotated in all different ways, the Z-seam will be in different locations on every dog. There are times this won't matter. There are times this will matter. Generally speaking, you might want to keep that off. Here's where things get a little tricky. If we'd like to arrange just this bed, you may click the bed so that it is highlighted, and then simply click Arrange Objects on Current Plate. The program will arrange them to the best of its ability and space them properly to avoid collision. You will also note the dogs did not rotate. Had I checked Auto Rotate for Arrangement here in this interface, it would indeed apply to this Arrange tool. And you'll see the dogs are now facing every which way. You can see why it might be ideal not to use that feature. This brings us to the main difference between the Per Plate Arrange tool and this Global Arrange tool. Using this Arrange button, we'll attempt to arrange the entire project onto as few beds as possible. There are very few instances where this is something you would want to happen. Instead, it is more likely you would like to arrange each individual bed independently. Speaking of, you can actually do both features using keyboard shortcuts. To arrange the entire project, press the A key. To arrange just this bed, hold Shift and press the A key. And this is how you arrange models in Creality Print 6. But Mr. Rundown, how do we actually slice this model? Let's do that with this single doggo. We will start by pressing the Arrange key to center this model, and we will begin applying its parameters. I am going to start using the 0.2 profile. This means the layer height is 0.2, and it will apply a series of defaults for all categories for the 0.2 layer height with a 0.4 nozzle. Should I switch to a higher resolution or a lower resolution, a larger layer height or a lower layer height, it will apply the Creality default profile for that layer height. Many of these settings will need to be changed due to the smaller layer height, and this all happens automatically. However, does that mean we should just throw this dog into the fire and print exactly how this profile is set? No, we should not. We need to learn and understand as many of these parameters as possible. However, when you are just getting started, there are a few that are critical to learn and know, while the rest can be saved for learning a little at a time. The first thing we will look at is tab number 1, the Quality tab. Here you will see the layer height matches your profile height. We will leave all of this as it is. Looking at the next section labeled Seam, this is your Z-seam. All 3D prints will have a Z-seam in one way or another. There are many advanced ways to work on positioning this Z-seam where you'd like it in order to try and mask it as much as possible. For now, we are going to go over the basics of how to position it. You will see it's defaulted to a line. To see what a line looks like for this particular model, go ahead and press Slice Plate. What we are looking at now is your G-code preview. In other words, a preview of the sliced model. Here you can see these white lines representing your Z-seam. Creality Print has attempted to align the Z-seam with contours of the model. This doesn't always work out in all areas of the model. Here you can see inside the leg, centered on the tail, along the edge of the ears, but unfortunately down the front face of your dog. This may lead you to want to try positioning the Z-seam somewhere else, preferably out of the common viewing face of the model. Let's choose Back and choose Slice Plate. Would you look at that? The whole front face of this dog has no visible Z-seam. Where did it go? It's back here, behind the model. Being that this is a doggy that's going to sit like this may actually be ideal. And this is how I do it for this model. Because when looking at the dog face on as intended, there's no Z-seam at all. It's hiding right here behind the dog. Each model will affect the Z-seam differently, and you will simply want to experiment with the different types of Z-seam options, pressing Slice Plate each time, and simply having a look at where it puts that Z-seam. This one, for example, created little dots of seams all over the model. Probably not a good idea. However, if this was a lizard or something with a scaly, bumpy surface, all of these little dots might be hidden, and this might actually be a good reason to use it. For now, let's stick with Back. Returning to the Prepare screen, where it'll allow us to continue slicing, we will move on to the Strength tab. This is tab number 2. In here is Wall Loops. This one is super important. Wall loops add print time, however, they significantly increase print strength. The default is 2, and many times this will be acceptable. However, if you're printing a potentially delicate model, such as an articulated dog, which this is not, you may want to increase the wall loops. Let's have a look at what walls actually look like. You may also hear walls regarded as perimeters. Let's go ahead and see what these walls or perimeters look like. Right now we have 2. Choose Slice Plate, and we will preview this print by clicking here on the green dot and pulling down. We are now looking inside the model as it's printed. Here is your infill. Here on the edge are the walls. You know how to do this. We talked about navigating earlier, so I'm zooming in with the mouse, holding the wheel and dragging it around. Here are the perimeters or walls. 1, 2, followed by infill. But let's say you think that's not strong enough. For example, perhaps with only 2 walls, this ear may break. We may go ahead and add a 3rd wall. To preview that 3rd wall, again, we'd have to reslice the plate. This time, you will see where there used to be 2 walls, there is now 3 walls. 1, 2, 3, followed by the infill. Returning to preview, we will now look at your infill. I want you to focus on infill density and infill pattern. These are the two critical parameters that you need to understand. The single most important is infill density. That is the percentage of the inside of this model that will be taken by infill. More infill creates more print time, more filament used, and a heavier, thicker, stronger model. Less percentage, less density creates a more hollow model, faster print time, less material used, less physical strength and weight for that model. Typically, between 8 and 15% is an acceptable range and is likely what you will work with for most of your models. To visualize this, let's drop down to 5% and slice this model. Using the preview bar, you may scroll down and you will see 5% infill density. Big spaced out squares, leaving lots of empty space inside the model. Let's say you want this dog to be heavier and stronger, and we go up to 20%, which I would like you to consider a lot of infill. Unless you really need weight and strength, you won't typically use 20%. I would consider 6% on the low side, 15% approaching the high side, 8 to 15 your common density percentage. Go ahead and press slice plate. Check it out. This is the same infill pattern. Now it is 20% compared to 5%. You can see how much more material this is, how much smaller the boxes are, and how much more of this dog is filled up with that infill. We are looking at a standard infill pattern known as grid. I do tend to work with the grid infill pattern. However, sometimes people claim grid infill has a tendency for the nozzle to rub against it while printing. You may change this to one of many other patterns. A very common pattern is gyroid. Gyroid is commonly chosen as a smoother, easier to use infill that avoids the dragging of the nozzle. Slicing the model, you will see the pattern has changed from the grid pattern to this wavy gyroid pattern. Let's return to prepare and move on to the next tab, which is speed. This one is super important. I cannot stress enough how important this is. So many people have problems printing because they are obsessed with speed, or they are simply not knowledgeable to the fact that speed exists at all, and they're leaving everything default, which on many of these profiles is simply way too fast. Your printer is melting plastic and then drawing with it one tiny little layer at a time, tenths of a millimeter at a time. Some of these features are small and delicate. All of these features require each individual layer to be printed and then cool and then have another layer printed on top of it. Your printer's extruder has a series of gears that are moving like crazy, that are pushing and pulling and pushing and pulling, extruding, retracting, extruding, retracting. The faster all of this happens, the lower your chance of success, the greater your chance of an extruder jam, of a poorly printed layer, of your model being knocked off the print bed, and a plethora of other potential failures. Be reasonable with speeds. It will protect you from wearing out or damaging your printer, as well as from having too many failed prints. Let's have a look at those speeds. Right here, we are looking at first layer speed. This is super important. This is the very first layer that your printer is going to make on the print bed. This is when there's absolutely nothing there, and it has to make this tiny little layer, of which every layer, the entire print, will be built upon. This doggo has pretty big surface area, but this is not always the case. Some models have very, very, very small initial bed contact and lots of little tiny parts that must successfully be printed for the entire model to succeed. And if even one of the tiny little details fails and is lifted off the print bed and tossed around, the whole model is a waste and you're going to have to start over. Therefore, printing the first layer and then the first infill over that layer should be done very carefully and slowly, because once it's successful, the chance of the following layers printing successfully is very good. If you attempt to print little details like this too fast, the chances of losing a finger or a vertebrae or a leg or something small is getting higher and higher the faster you attempt to do it, and that will cause the whole rest of the print to suck and, of course, most likely be a failure. Because without, for example, this one vertebrae, if this initial layer was gone, it fell off, it got dragged away, it doesn't matter how good everything else printed, your print is garbage and you're gonna try again. So you will need to make decisions on the first layer. This first layer is set at 60 MMS. It sounds pretty slow, but consider just a few short years ago, 60 MMS was considered fast for the entire print speed. You will see the profile already has it turned down comparatively slow to the rest of the speeds in this profile. However, a difficult print like this, you should go even slower. Ask yourself, in a 3 or 4 hour print, what difference will 3 or 4 minutes make to you if it means a more successful print? So that is the very first layer, bed to nozzle. First layer infill is how fast it will print that very first layer of infill on top of that first layer. Here you can see on the dragon, this is the first layer of gyroid infill. Now imagine how difficult this is for the printer. It needs to make this complex infill pattern on top of a single layer of filament directly on top of the print bed. This first layer of infill can pull, tear, rip, or remove one of these small features clean off the bed. However, once that first layer is down and this first layer of infill is down, you now have strength for which the printer can ramp up its speed and continue the rest of this print based on that strong, solid foundation, allowing it to move faster. This is why your first layer infill is also important to be slow. You can see it's defaulted to 105. I like to get down to 60, 70, or 80. If I'm printing a giant box or the dog with a big giant first layer, it may not matter as much. But a print like this, with lots of very small initial prints with very minimal bed contact, slowing it down even more can be helpful. Move on to other layer speed. Here is the outer wall. That kind of speaks for itself. It's these outer walls. You want them a little slower. Inner walls can be faster. Infill can be faster. Your top surface, again, very important, the top surface. I'm impressed with this profile in Creality Print 6. It's not pushing the K2 Plus pretty hard. But however, that may not be the case. For example, let's look at the K1 profile. Here you can see the profile for the K1 is pushing the machine pretty hard. I seldom recommend pushing all the way to 300, and I tend to move my prints more down into the 180s. You can simply go ahead and type it all in. Over time, you will learn with practice what speeds your printer can reliably handle things. However, the slower these speeds, the better the chance of a successful print, avoiding things such as extruder jams, knocking the prints off the print bed, failing your first layer, etc., etc. And the difference between 200 and 250 and 300 is not as much as you think. Generally speaking, being in the 180 to 200 area is a good safe place to be for printing consistently with very few hardware or print failures. I highly recommend, especially to newer users, to lean on slower speeds. From here, let's move on to supports. This is a really difficult topic. I have entire videos on supports, and I use multiple slicers to demonstrate them. I recommend, regardless of the slicer you use, that you watch those videos. All of them have principles that apply to any slicer. The only difference would be the user interface. Let's go over the basics of supports. Your printer needs something to print on. It starts by printing on the print bed and then building each individual layer on top of itself. Should the nozzle end up needing to print something without anything underneath it, we need to add supports because the nozzle cannot print on thin air. Some designers work very hard to create models that require no supports. This little dragon is one of them. He is printing flat on the bed, and every layer was designed on purpose to be on top of previous layers, meaning no supports are necessary. However, this acorn, for example, has a flat ceiling hovering over the bed with nothing underneath it. Your printer is not magic and cannot print this without something to print on. We need to print supports. Supports are complex. However, working with the basics of supports is not so complex. There are normal supports and tree supports. Tree supports are generally preferred to normal supports. However, that doesn't mean tree supports are always better. Tree supports are best when working with many small or curved features. This Godzilla is a great example of a model meant for tree supports. To enable supports, simply go to the Support tab and check the Support button. You will choose your type right here, normal or tree. Normal will create straight, flat supports. Let's see what they look like on this acorn. With normal selected, go ahead and slice the model. This is what normal supports look like. You can see the printer is building these thin supports along with the model so that when it reaches the roof, there's something for that roof to print on. Here you will see what's known as an interface. This interface is a special, thin, flimsy surface that is meant to be easily removable from the print. That way you can separate this support from the actual model when the printing is done. Then there is tree supports. To use tree supports, go ahead and select Tree Auto. With Tree Auto selected, click on Slice Plate. Here you can see a somewhat extreme look at tree supports. They're called tree supports because they have trunks and branches. These small branches allow tree supports to support very tiny features with very tiny supports and enable them to, in theory, come off those small features more easily. You will need to learn to work with supports to make good decisions on which type and how much you need. Relying on the slicer and its defaults is not generally a good practice. For example, the default angle is 30. Without needing to get overly technical, all you need to understand is that raising this number will increase the amount of supports. Lowering this number will decrease the amount of supports. For example, let's slice it with a default of 30. Here you can see all of the overhangs in which Creality Print decided to apply supports. For this particular model, I'm going to say it's pretty obvious where supports are needed, and Creality Print did a pretty darn good job. But let's say you're like, nah, you're crazy. These cheeks need support. I don't know here, this little X needs support. You may go ahead and raise the threshold angle. Moving back to prepare, I'm going to raise it to 50. Here is that model resliced at 50. You will see Creality Print has gone ahead and supported the cheeks and more of these smaller overhangs that previously it was decided were okay without supports. Even the little X. This is a great opportunity to check out the next parameter, which is on build plate only. Looking at this model, you will see supports have been added on the model. For example, this little divot right here, there is a support that originates on the model as opposed to on the print bed. This is generally not desirable, so we want to go ahead and make sure it only makes supports originating from the bed, unless your specific use case absolutely requires it. We will check on build plate only and look for this eye support and this divot support to go away. Check the box, reslice the model. Here you can see the supports were removed from the eye and the divot. Moving along, let's go to the final tab at the bottom, labeled Others. This is very important. Here you will find adhesion modifiers. These are things such as brim, skirt, raft, etc. that are meant to assist in keeping your model on the print bed to avoid having the model separate from the print bed and fail. However, Creality Print has this set to auto. This is a really bad idea, and I need you to manually be in control of this feature at all times. For example, this mask has huge bed contact and unlikely needs a brim. However, should you choose a brim, removing that brim shouldn't be much of a big deal. This dragon is an articulated dragon meant to be wiggly jiggly and printed fully in place without supports, etc. Applying a brim to every one of these individual wiggly jiggly parts may indeed help this model stay put, but will likely ruin it and become a nightmare to remove. Currently, brim type is set to auto. Should you choose to use a brim, I suggest choosing outer brim only, not using auto. Go ahead and press slice plate, and we'll see what that looks like. The brim, signified in blue, is one layer of several loops around the model that helps avoid the model lifting off the bed. For this model, a brim might be a problem. However, if you're having trouble getting the model to stay down, you might need to use it. Another good example where a brim might come in handy would be something tall and thin like this, where you are afraid that the model might separate and knock over. Adding a brim will apply a little bit of extra security to help keep that model down and staying put during the print process. When the print is done, you simply peel this off. And because everything is flat and easy and nothing really fragile here, it should come off rather simply and make this a good candidate to work with a brim. If you'd like no brim, be sure to click this and choose no brim. In many cases, you will work with no brim. I would enter your projects with the mindset of not using a brim unless you feel the need to use a brim. For example, this dog has a lot of bed contact. It is very likely that using a brim is unnecessary. This is what a brim looks like on the dog. You can see it's most likely not needed, not helpful, and only complicating your print and your post-print process. Depending on the filament you are working with, this brim may separate easily. However, if you are working with a stronger filament, it may prove more difficult and ruin the overall visual quality of these outer edges. For this model, you should go ahead and choose no brim. We will now need to set up our filament profile as well as our nozzle and bed temp. Your nozzle and bed temp are set for each filament profile. Choose this pull-down menu right here, and then choose this pull-down menu right here. You will see there are CR filaments here, and there are hyper filaments here. If you are working with a Creality filament, such as CR PLA or Hyper PLA, simply choose that filament here. If you are working with a different brand, you will start by choosing generic. For example, if you are using a different brand of PLA, you will choose generic PLA. This will activate the generic PLA profile, and you will see the current nozzle and bed temperature. To enter the filament profile and gain access to the nozzle and bed temperature, you will click the pencil right here. Various materials and beds require different temperatures. The average PLA in a high-speed printer like this will work well at 220, and I suggest changing this temperature to 220 and working with 220 unless you feel or know of a need to work differently. More and more print beds are releasing that utilize different temperatures, some much lower than your traditional temperatures. When working with the average smooth or textured bed, 60 is a good temperature to work with, and I recommend working in 60 unless you see a need or know of a reason to work higher or lower. Here in Creality Print, you have the ability to set temperatures for different beds. You can set the temperature for a smooth PEI bed, textured PEI bed, a custom plate, for example, a third-party BQ cryo plate, or an epoxy resin plate. For example, you can set the smooth plate to 59, the textured to 60, the BQ to 36, and the epoxy resin plate to 1. You will then want to save as or exit out, and when it asks if you'd like to save the changes, you will say yes. You will then see, with the smooth PEI bed chosen, the generic PLA profile chosen, your nozzle temp is 220, your bed temp is 59 degrees. Should I choose to a textured PEI bed, you will see your bed temp is now 60. A customized plate, your bed temp is now 36. Your epoxy resin plate, your bed temp is now 1 degree. Again, I chose these numbers just so you can see how it retains your bed temp for different beds. This keeps you from constantly having to change the temp every time you switch between beds. This is also a good opportunity to save your own third-party filament profile. Let's say you're working with Elegoo filament, and these settings work well for that Elegoo filament. You may save as and type in Elegoo PLA and press OK. Then press Save. X out of there, and look what you've got here in your drop-down menu, Elegoo PLA as a user preset. Now, when working with Elegoo PLA, you simply choose this pull-down. However, let's say you have multiple colors of Elegoo filament and you want to differentiate them. When working with this print, you can simply click the color up here and change that color while you're working on the project. Or you can create new profiles. For example, click into the pencil, save as, and call it Elegoo PLA Red, and press OK. Scroll to the top of Basic Information, click on the default color box, and choose the red that closely resembles your filament. You may even change the vendor to say Elegoo. Then press Save and exit out. You now have Elegoo PLA and Elegoo PLA Red in your presets. Of course, you can go ahead and change the original one to a specific color by doing the same thing. For example, I will choose black, press OK. I will choose Save As and name it Elegoo PLA Black. OK. Press Save and exit out. You now have the original generic Elegoo profile, which you can keep or delete, Elegoo PLA Black and Elegoo PLA Red. I will click on Black, and you will see the model is now black, and that profile has been applied. I can switch to Red, and now the model has switched to the red Elegoo profile. There are other settings within the Filament tab and Cooling tab that are worth learning that can help you improve print quality on more difficult models. Now that you have sliced your model, it's time to print it. You may switch between Prepare and Preview at any time. However, once you make any change you will need to reslice. Now that you have all of your perimeters set and you've sliced your model, you will be here in the preview screen. This is your G-code. When you export this file, everything you just did is turned into a G-code, which is sent to the printer, and the printer uses that as the instructions to build this model. On this preview screen, there's a lot of information. For now, let's focus on the most important detail, and that is your print time. You may go ahead and make adjustments to your walls, size, infill, print speeds, etc. to bring this time down if you find it unacceptable. You may preview how the model will print by grabbing this slider here with the left mouse button and dragging down and up. This is showing you layer by layer how the model will print and what it will look like. To send it wirelessly, you would simply press Send Print. There are a few ways to print from here, assuming you have configured your printer, connected it to Creality Cloud, and logged in to your Creality account in the home screen of Creality Print 6. You may go ahead and send this print wirelessly to your printer directly from Creality Print 6 by clicking Send Print. On this screen, you will need to choose the printer that matches the project file you sliced. I sliced this using a Creality K1 profile. I would need to choose my K1, whose name is Spender. Currently, my K1 is offline. If it was turned on, it would show up as online. I would choose that. You will see it shows me the K1 here, and I would choose Start Print. A second option is to upload this to Creality Cloud. This is my favorite way to print to Creality printers. You can do that by choosing this up arrow and choosing Upload to Creality Cloud. Again, assuming you are logged in, you would press Confirm, and this file will be uploaded to your Creality Cloud account. Upload successful. You would then log in to crealitycloud.com, click on Workbench, and either send your file to a printer from the Print Files section, clicking on Locally Uploaded Files, or going into the Workbench and choosing the printer you'd like to print from, and then the file from there. The final old school method would be to choose Export Plate Sliced File, and then either use the name of the file it gave you, or type in your own file name, test dog tutorial, and press Save. You now have a G-code file of that test dog. You may copy it onto a memory card, stick it on your printer, and print it from there. Now that you are done working with this project, be sure to press File, Save Project As, and save this project as something you can easily recall later. Test dog, K1, Creality Print 6, 200%, lesson, whatever. You see how it is a .3mf? That is the entire project file, not just the sliced G-code file. Now you have a saved G-code and a saved 3mf project file. You cannot reopen a G-code file and make changes. You need this project file to do that. You can always reslice the project, but you cannot re-edit the G-code. Therefore, you may save the project and the G-code, or just the project. That's up to you. However, saving the project is a must. There is so much more to learn when it comes to working with Creality Print 6. These basics will help get you started in moving from an STL file to a printed model. I'm Greg Adventure, and you're on 3D Rundown.